Hello. Hopefully you can see me and hear me. If not, I will try and record this, so I'll release a recording to you if you need it. But it was good to see everyone in the room. That's different. I get to see a nice virtual pan for everyone. All right, so what I've done is I've called this Automating Pragmatically, because what seems to happen is I get a lot of questions emailed over instant messages on Twitter about people having issues just around automating. Not so much testing. People are less concerned about testing nowadays. They're much more concerned about automating. How do we do it well? What's the impact on me, on my career, things like that. So I've knocked together a quick slide deck to go through this. So hopefully you can see the slides as we go through. I give a blurb, but I'm not going to go through the blurb in detail just to try and get through this, but people often have a lot of questions. Now, one of the issues that we have with automating is just the words test automation, because clearly everyone knows that we don't actually automate testing, right? We automate activities within it, we automate the execution of things, that kind of stuff. And now people are starting to say things like automation in testing, rather than just test automation, right? Because test automation is a very, very vague set of terms. So people are trying to get around that concept by saying automation in testing, or tool support, or concepts like testing versus checking. Now, what's important about this is not the actual words that other people are using. What's important is the fact that people are trying to use words that are more distinct in terms of conveying a specific concept, right? So rather than saying test automation, people are trying to be more specific and say we check for things, we automate within testing. But what's even more important is that we use our own words when we're describing this, right? Because a lot of the time the issue is how we communicate and think about test automation. Because one of the issues we've got is automation is a word that was created in the 1940s, right? And I'm not really sure whether it's a verb or whether it's a noun. If we say test automation, does that mean we're trying to automate things? Because if it's a noun, then we end up starting to count what we mean by test automation. Now, there are a whole bunch of other words that we could be using, right? We could say automate, which is a verb. We could say automated. We have automated something. We are in the process of automating something. And the real dictionary word for converting something into a more automated process is automatization rather than automation. And if we stick to it as a verb and a dictionary definition, then we have the notion of an automator, someone who actually automates something, either a programmer or a tool user. And then we have the concept, which is very often forgotten when we say test automation, of an automaton. Something that has been automated, like the script or the actual configured tool that is doing something, the thing that does the work. So then we've got the notion of test automation of, well, why do we even include the word test? Because automation is a completely independent concept, right? We can automate things without it being anything related to testing. So we include the word test because we are much more interested in the context of testing, supporting our work in testing. And within that, we have a strategy. We have the high-level aims that we want to achieve when we're testing. We also have our approach, right? How we will do things. So we already have high-level goals and understanding of what we're trying to do. So all we really do then is automate support for our aims within that. But a lot of people seem to think of, anytime they think of automation, they think of it must be something to do with testing. Then we always have discussions like, well, no one ever says programming automation or software development automation. And that's because it's natural to automate things because we're human. And when we automate things in software development, we actually give them different names. In testing, we tend to say test automation, and everything is test automation. In software development, we've got continuous integration. like building something every time we check something in, running unit tests as we do it, automated build processes, dependency management, so we download the dependencies automatically, we just configure them, code completion when we're using the IDEs, static analysis, we've got compilers, assemblers, interpreters. All of this is automated work and tool support within software development. It is natural for us to automate stuff. But it seems like only in testing do we ever really get hung up on things. So I'm going to try and suggest that we use our own words as much as possible. I personally try and avoid saying automation. Right, I'm using it in this, but it's a marketing word. I try and avoid saying test automation. Normally what I'll say things like is, I am in the process of automating this particular process. I've automated this particular part of the system. I've written assertions to cover the acceptance criteria for this particular story. So using other words, I can still be understood. I don't have to say I'm doing test automation. What are you involved in? I'm automating. Right, I'm more specific about what I'm describing when I'm saying this. The other issues people have is when they go online, it's hard to know who to actually believe about things. Because people say, well, we shouldn't be automating through the GUI. All your testing should be through the API. Well, we don't have an API, but all your testing should be through the API. Doesn't really matter if you've got an API or not, it should be there. We shouldn't really do GUI automation. GUI automation is bad, GUI automation is flaky. BDD is not testing. Now it's true, BDD is not testing, but the tools that support BDD can be used for automated execution if you want that layer of abstraction. And it's about trying to identify the concepts within this and how they apply into our environment. Nothing is actually bad, nothing is an absolute. But we have the issue that if we don't have the experience and someone's telling us not to do something or to always do something, how do we know whether to believe them or not? So one of the things that I do is I look for absolutes when people are talking, right? So never automate through the GUI. There's an absolute never in there. So I distrust absolutes. Now, when I'm communicating, I try and avoid absolutes, but it's hard, right? Because we think in absolute terms. So I will use absolutes when I'm communicating, but then it's your job to try and get past those absolutes and disbelieve me when I'm saying absolutes. So look for the exceptions. Look for the but moments. So if you say, we're automating through the GUI and someone says, well, you should never automate through the GUI. You go, well, but we don't have any other way to automate because we only have a GUI. We don't have an API. You have an exception in there. So then what you do is you look for people who are doing that, who are succeeding. Then you try and look for commonalities within their approaches. The important thing is that we have to build our own models of how we approach this. And the only thing we really should believe are our experiences, which means that we have to actually do stuff, try things to develop those experiences so we can learn from. Or have people on our teams who've done it before and draw on their experience. But the issue that we face and as an industry is that a lot of people are thought leaders and say things online and we either trust them or not, and we get polarized and we use their language, which can make it then hard to think about the situation in our particular environments. So I'm encouraging you to own your language and own the approaches that we use from our experience. Then we have the issue of how people handle things in the future, right? Do all testers need to code? Is automating part of testing or not? Do we need to automate in order to get a job, right? I get asked these questions a lot. People are worried about this stuff. Now, the issue is, in terms of do we need to automate to get a job, there are people who are putting out job specs that say, in order to get this job, you must be able to write code in Java and you must be able to use these tools. If you don't know how to do that, you will not get that job. But that doesn't mean you won't get a job, because there are plenty of jobs that do not require it, that do not have those specifications. And if you do learn a particular tool or particular language, that doesn't mean that the next job is going to want those skills. So we have to be careful if we try and chase automating simply to get jobs. What we should be doing is looking at our particular environment, right? Does it actually matter if you can automate or not within your particular environment? Because we work in teams, right? It's rare that we work completely in isolation, right? So when we work in teams, one of the arts for creating a team is you have multiple people with multiple skill sets and they all work in combination. So some of them will be good at automating, some of them will be good at coding, some of them will be good at testing from requirements, some of them will be good at accessibility. That entire range is what makes a team successful. All those mix of skills are what give the team the requisite variety to respond to changes in the environment. If everyone on the team is a specialist, when that person that specializes in whatever it is releasing to the environment is on holiday, you can't release anything. That means we need a broad range of skills in there. So in one sense, we don't really have to worry about it. What we have to do is figure out how can we maximize our range of skills within the environment that we're in. So then it becomes things like, well, what does our current environment need? Where are the current gaps in your process? Perhaps you're not testing deep enough at the HTTP level. Perhaps no one's looking in the database when you actually test things. Those may be more important skills to develop than automating. The other thing that we have is programming is hard, right? Automating is hard, right? I know this because I've done it. And learning how to code is hard and people make mistakes. But a lot of the time when people are looking at this, they think it might be quite easy. So they think, well, I'll just learn how to code in Java and then I'll be doing test automation and then I'll earn double the salary. If you're not actually interested in coding, and by interested in coding, I mean you have to be interested in writing code, writing applications, learning all the patterns, learning all the design skills, reading lots of books on programming, keeping up to date. Because in order to get good at this at a code level, you have to develop the same skill sets as a professional programmer. And that's going to take time, and you have to be interested in programming. And if you're not, then there are other things that might be easier to pursue. In terms of, there's a massive overlap between security testing, hacking, and software testing. The same thought processes, but more a different slant on the technical skills. Exploiting the technology for weaknesses. Exploring it for issues. There's a much bigger overlap between security testing than there is with automation. But people seem to underestimate this. And these skills are in demand, like ops skills, being able to deploy things, understanding how Kubernetes or Docker works. These are very technical set of things that we have to learn. But there's no reason why someone in a QA or testing background couldn't learn them as well as programming, because they are on the fringe. Programmers have to learn them. We could learn them. Performance is still an undervalued aspect in systems. Now, one of the interesting things for me is that a lot of security professionals do not know how to code. They know how to use tools, they understand technology, but they don't really know how to automate things. A lot of performance testers don't necessarily know how to automate things, but they understand the technology. There's other things like, how is AI going to impact us? I've no idea, because it's hyped up. But these are weak signals that we need to keep an eye on, rather than just continuing to pursue automation. But I'm not saying this to put any of you off, simply because I can't do that, because I really like programming. I program all the time, so I'm never going to stop anyone learning how to code if that's something that you're really interested in. But what we should be doing is looking at what are the gaps in our current environment and trying to fill those. And identifying the path that is most important to us. Because there's the concept that we all have natural inclinations to things. Those will be our strengths. We should build on those and push them further. So if we've got an analytical mindset, we should be pursuing that. If we like finding problems, if we're good at that, we should pursue that. Doesn't mean we should ignore our weaknesses. A lot of people do not build up on their weaknesses and improve them. We should keep doing that. But I think the aim is that we should be interested in software development as a whole. So not just coding, not just testing, but also analysis, design, requirements, management, accessibility, that whole range of things that the entire team needs in order to succeed as a project. If we have skills in any of those areas and we can incorporate those into our testing, we will improve and be valuable even if we can't code, right? So look at all the different skill sets that you have and figure out which ones to pursue. And take a long-term view, right? A lot of people take a short-term view. I've been doing this for whatever it is, 20 odd years. So over that time, I've had a chance to learn design, analysis, architecture, management, programming, accessibility, security testing. Over time, we build up lots of skills so long as we can integrate them. But what I want to try and do is, I don't seem to think about test automation and have the same issues that other people do, and I think it's because of the models that I use. So I'm going to try and explain some of the models that I use when I'm thinking about this and see if they help. So when I'm thinking about testing, I'm thinking about comparing something to a model of the thing, right? And the model is represented in terms of the requirements or information that I've built up. And I have to do clever multiple ways of comparing these two things together. So when I'm chunking up my approach to testing, I have to think about how I model things, what techniques I've got, where the information is coming from, how I'm going to observe the system in action to see what is happening. And that requires me to develop more an understanding of the technology and tools that allow me to go deeper in there. Reflecting on it and thinking about it, making time to learn, interrogating it. So I'm not just watching things as they happen, I'm drilling in deep to check risks or issues, and having the ability to manipulate the system in multiple ways. And some of that manipulation is going to be through tools. Some of that manipulation is going to be automated. Some of the interrogation is going to be automated. But it depends on the skill sets that I'm bringing into play when I do this. So then when it comes to automated execution, when I'm thinking of the application, I'm thinking of the system as a graph. So a directed graph, nodes, flows. Then what we're doing is we're exercising paths through the system. Each of those paths consumes data. So there's data flows through the path. Some of the data controls the path. If someone is less than 18, then do this. If someone is more than 18, then do these things. So the data has an impact on the path. Then within the data, we've got partitions of data. So if someone is over 18, it doesn't really matter how much older, anything above 18 is equivalent. It's in a partition. And we abstract that into concepts. Valid age, valid email, invalid email, right? We've got partitions which are abstraction. And abstraction is key, a key modeling approach when we're modeling. There's multiple ways of modeling systems as graphs. You've got events, states, flows, other ways of doing this. And this can lead us into model-based testing, which is underexplored. And all testing essentially is model-based. When you're doing exploratory testing, you have a model in your head of the system, and you do model-based testing as you do that. When we do automated execution, we have a model of the system that we've broken down into steps, and the model is codified in the automated scripts. We could model the system formally and feed it into a model-based testing tool where the execution is actually driven by that modeling. Modeling is key to what we do. Then the paths through the system. All our execution follows paths. If we're doing it manually, then we might have written a test script, or we might be exploring the system based on some sort of objective. But we will exercise paths through there. And if we're not aware of that, then we have no way of understanding the coverage we're doing. Now, when we approach this through automated execution, the code that we write represents a path. We're doing model traversal through an algorithm if it's model-based testing. You've heard of keyword-driven testing. If we were doing keyword-driven testing, those keywords in sequence represent a path through the system. If we're doing BDD, then what we have is a declarative implementation where our BDD does not tell us exactly what steps we're doing, but someone has to put a step definition implementation behind that declarative implementation. So there's always a sequence represented in there, which is an abstraction of the flow through the system. I should really have diagrams for this because it's kind of graphic, but I'm trying to explain it, so hopefully you can visualize it. Now the data flows through this. So if I've got two steps, a login step and a create a new user step, we've got data for the username and password for the login, then we're creating a user that has a username and an email and a particular role. This leads us on to data-driven testing, because we can create a set of data which we feed through this path to then have it cover multiple conditions. Now, one of the issues with data-driven testing is that if people don't know how to model this or create abstractions, they put too much data in there. Whereas really what we're doing is we want to only expose the data that is important to understand the reasons for covering a certain path. If we're using behavior-driven development tools, we have tables of examples where we put the data in, and it becomes essentially data-driven at that point. Now we can get a lot of value if we understand the paths and understand how we pull out the data to give us a lot of coverage across a certain path. Certain paths are going to require invariant data, like we can only create a new user if we come in as an admin role. If we're logging in as a non-admin, we can't even do this. So we don't have to say that we're logging in as an admin user, because in order to create a new user, we have to be. It's an invariant. Then everyone knows about equivalence partitions, but people tend to think about equivalence partitions purely as a kind of single input technique, whereas data is equivalent in different ways at different points in the system. And we have to be aware of that when we're exploring paths. Otherwise, we do too much testing. This is a way of funneling down our testing. Now, people often talk about coverage and how do you know if you've automated enough? All coverage comes from models, right? That's what it means. It's how much of this model are you covering? We have requirements models. So how many of these requirements have we covered and how deeply have we done it? Path coverage, data coverage. All of this is different way of modeling, different way of doing coverage analysis. Now, one of the most important things, I think, in terms of distinctions is between strategic or tactical automating. When you are learning how to automate, the temptation is going to be to jump to strategic automation too quickly. So by strategic automation, I mean writing lots of code, writing lots of tests. It's long term. It's going to be in continuous integration. It's stuff we have to maintain and keep running. We'll be using specific libraries and specific tools because we've agreed on them as a team. The biggest mistake that I've seen people make, and I've made when automating, is jumping to strategic automation when we didn't need to. A project that we were building in, 6 months, that ultimately, once it's deployed, is never going to be maintained or used again. There's no point building strategic automation for that, because it's not going to die. All the effort that we put into making something maintainable is not going to help us for the long term. What we should have done is be more tactical about automating, not worrying so much about it being maintainable, making it support the testing that we're doing. And things like uploading test data into the environment, very short term, ad hoc scripts that may or may not be maintainable. Now, when we're learning how to automate, automating tactically is something that most people can do because it's very short term. It can be messy. We don't have to understand all the different approaches for programming. So I try and split my understanding of automating into whether this is strategic or whether it's tactical. And it's a lot easier to teach people to do things tactically. But when we are automating, we do have to make a distinction in our head whether we need to be pursuing this strategically or not. So ultimately, when we are automating or testing, we need to know what our outcomes are. A lot of people would phrase this in terms of we need to know why we are automating. I think that we probably already know why we are automating. The important thing is to know why we are actually testing. What is our test strategy? What are we attempting to cover? We know what our approach to doing it is because we've got our test approach. So if we know what our outcomes are, then it's basically a case of, well, we can automate parts of those. The thing is, we can only automate what we know is possible. If we do not know that it is possible to automate it through the GUI, we won't even attempt to do that. If we don't know that it's possible to automatically upload things in a database, we won't do that. If we don't know that there is an API that we can automate, we won't do it. So we have to expand our range of what we believe and understand is possible within the system that we're doing. And we do that by getting more information about the technology that we're using, expanding our other skill sets so that we know what injection points we have when we're testing. Because the possibilities for injecting manipulation don't just limit us for automating, they also expand what we can do when we're exploring. If we know there's an API, we don't just have to automate the API. We can interactively engage with the API through tools or scripts to make certain things work to support us with our exploratory testing. When we're doing experiments, we should do it tactically, right? A lot of people want to leap to strategic automation. But what we need to do is learn so that we can work from our own experience. And we do that tactically by targeting particular technologies or libraries or tools. And it's a very low risk way to work because it impacts us as individuals. Strategic implementation is something that we build up by refactoring. A lot of people start strategically, so they want to build a framework. They want to build an all-encompassing suite. What we do is we start tactically, then we refactor what we're doing tactically to something that can operate more strategically. And as we're doing that, we will learn more lessons and then bring more people in. But the key thing that anytime anyone asks me about with what should I learn, how should I approach this, what issues have we got, is the notions of responsibility and ownership. We have to take responsibility for how we communicate automation. So we use the right words that are appropriate for the environment we've got. How we think about it in terms of what we think is valid, what we think is not, and taking ownership over it so that we're not just relying on what other people say, right? What we're relying on is us taking ownership of the approaches and techniques and tools and language that we have. And we don't have to do that individually, right? We can learn from everyone that's in the team and make these decisions on a team basis. So I've gone through that relatively quickly to try and leave time for questions. Most of the time people have issues simply because they're relying too much on other people. So that's pretty much everything I wanted to cover.